Quantitative aspects of electrolysis. Michael Faraday was the first scientist to describe the quantitative aspects of electrolysis. Faraday's laws of electrolysis. After his extensive investigations on electrolysis of solutions and melts of electrolytes, Faraday published his results during 1833-34 in the form of following well-known Faraday's two laws of electrolysis. Solutions means solution of salt in a solvent, solution of the electrolyte in a solvent, and melts means molten electrolyte. For example, solution means if NaCl is dissolved in water, then it will be considered as solution of electrolyte, and if molten NaCl is used, then it will be considered as melts of electrolytes. First law, the amount of chemical reaction which occurs at any electrode during electrolysis. The amount of chemical reaction which occurs at any electrode during electrolysis by a current is proportional to the quantity of electricity passed through the electrolyte, solution or melt. Now, what is the chemical reaction taking place at the electrode? Suppose in the electrolysis of solution of copper sulfate using copper electrodes, the chemical reaction taking place at cathode is like Cu2 plus 2 electrons forming copper. So what kind of reaction it is? It is reduction reaction. Now the amount of copper ions which are changing into copper atoms or solid copper will depend upon the amount of electricity passed through the electrolyte, will depend upon the quantity of electricity passed through the electrolyte. For example, in this balanced reduction reaction, it can be seen 1 mole of copper accepts 2 moles of electron to form 1 mole of copper in solid state. These are the copper ions present in aqueous solution. So the amount of electrons used is 2 moles of electrons. Now charge carried by 1 electron is 1.6021 into 10 to the power minus 19 coulomb. This is the charge carried by 1 electron. 1 mole of electron means 6.022 into 10 to the power 23 electrons. Therefore, charge carried by 1 mole of electrons will be, this is Avogadro's number. Charge carried by 1 mole of electrons will be Avogadro number multiplied by charge carried by 1 electron. Now, in the discharge of 1 mole of copper ions, 2 moles of electrons are required. So, amount of charge required is 2 times this value. 2 into Avogadro number into 1.6021 into 10 to the power minus 19. So this is the amount of charge which is utilized. This many coulombs are utilized in changing 1 mole of Cu2 plus ion to 1 mole of solid copper. So this is the first law, that is the amount of chemical reaction depends upon the quantity of electricity passed. Flow of electrons constitute electricity. So whatever is the amount of charge will depend upon the quantity of electricity passed, because Q is equal to I into T. So amount of current passed will decide the amount of charge. Second law, the amounts of different substances liberated by the same quantity of electricity. Different substances, the amount of different substances liberated by the same quantity of electricity passing through the electrolytic solution are proportional to their chemical equivalent weights. Equivalent weight is equal to atomic mass of metal divided by number of electrons required to reduce the cation. If there are 2 electrolyte solutions, let it be 1 and 2. And the same amount of electricity is passed through both the electrolyte solutions. Then, if in solution 1, amount of substance deposited is M1 and in solution 2, amount of substance deposited is M2. Then, amount of substance deposited in solution 1 is directly proportional to its equivalent weight, and amount of substance deposited in solution 2 is directly proportional to its equivalent weight. So if the same amount of current is passed through two electrolyte solutions, then the amount of substance which is getting deposited at the electrode is directly proportional to their equivalent weights. So first law is the amount of chemical reaction taking place at any electrode will depend upon the quantity of electricity passed through the solution. Second law is if the same current is passed through two different solutions, then the amount of the substance deposited at the electrode, means different substances deposited at the electrode, is directly proportional to their equivalent weights. These two laws will be used in chemical calculations. During Faraday's times, no constant current sources were available. So general practice was to put a coulometer, a standard electrolytic cell, for determining the quantity of electricity. Now the quantity of electricity was determined from the amount of the metal, generally silver or copper, deposited or consumed. However, coulometers are now obsolete and constant current sources are available, and quantity of electricity is given by the equation Q is equal to IT. Q is in coulomb, I is in ampere, T is in seconds. So the amount of electricity or charge required for oxidation or reduction, this is the reduction reaction, depends on the stoichiometry of electrode reaction. For example, in the reaction here 1 mole of silver ion, aqueous solution, accepts 1 mole of electron, forming 1 mole of silver. So here what is the quantity of electricity required? Now in this case 1 mole of electron is required for the reduction of 1 mole of silver ions. So what is the quantity of charge present in 1 mole of electron? The amount of charge present in 1 electron is 1.6021 into 10 to the power minus 19 coulomb. So in 1 mole of electrons, 1 mole means Avogadro number of electrons. So in Avogadro number of electrons, the amount of charge present will be Avogadro's number multiplied by charge carried by 1 electron, and this is equal to 96487 coulomb per mole. So this is the charge carried by 1 mole of electrons. This quantity of electricity is called Faraday and it is represented by the symbol F. For approximate calculations, 1 Faraday is equal to 96500 coulomb per mole. Now see these electrode reactions. Here 1 mole of magnesium requires 2 moles of electron. Means it requires 2 Faradays of electricity. And 1 mole of aluminium requires 3 moles of electron. Means to discharge 1 mole of aluminium, 3 moles of electrons are required, or the quantity of charge required is 3 Faradays. Now charge is equal to current into time. Current is in ampere and time is in second, and charge is in coulombs. So in commercial production of metals, current as high as 50,000 amperes are used. That amounts to about 0.518 Faraday per second. In this equation, like equation for the reduction of magnesium, 2 moles of electron will discharge 1 mole of magnesium. Now suppose this whole equation is multiplied by 2, then it becomes 2 moles of magnesium ions require 4 moles of electron to form 2 moles of solid magnesium. So when 4 moles of electrons are there, then amount of magnesium discharged is 2 moles. 4 moles of electron means 4 Faradays of electricity. So amount of substance discharged depends upon the amount of electricity passed or the quantity of charge passed through the electrolytic solution.